Alright, today we're going to talk about how a line and a circle can intersect, how to find the intersections, what they look like, how many there are, all of that. So first let's talk about the possible outcomes. The intersection of a line and a circle has how many types of outcomes? Well, let's figure this out first before we fill that in. Let's go ahead and discover it. So let's draw all the possible intersections of a line and a circle. And then it says to also mark the points of intersection. So let's just draw ourselves a circle here. Now if I want to draw a line that's going to intersect that circle, how could I draw it? Well, I could draw a line any way I want, but I'm just going to draw one right here. Alright, well how many times did that line intersect that circle? Well, it intersected here, and it intersected over here, for a grand total of 2 intersections or 2 solutions. Alright, how else could we draw this picture? So, let's try another one. Let's start with a circle. How else can I draw a line that's not going to hit the circle twice? Well, I could draw one that's kind of like a tangent line. And I can see that this line is going to intersect this circle just once. So this is going to have one solution. Alright, any other options we can think of? Well, I can think of another one. Draw myself a circle. So it can cross a circle twice, it can cross a circle once. Any other options you can think of? Well, I can think of, let's say I drew a line somewhere out here. This line is never going to touch that circle, so therefore this would be an example of a no solution answer. And I can't think of any other way to draw a straight line in a circle and to get them to either intersect or not intersect. So that would make my final answer for the possible outcomes 3. So there's 3 possible outcomes. Alright, so now that we see what they look like and how many types of possibilities there are, let's talk about how to actually find them. Okay, so what they're going to ask you to do is to find the points of intersection algebraically. And all algebraically means is to find the solutions by hand. Don't use your calculator, actually do the math yourself. Now let's think about points of intersection. Remember, it's a point. So points will have the same x and y values. Sorry, that kind of looks like Andy. Let's fix that. Okay, so the points are going to have the same x and y values. These points, or this one point, is called the solution. So you might hear the directions say find the points of intersection or find the solution. It means the same thing. But since we're talking about a line and a circle, let's revisit what their general equations look like. We like to talk about the slope-intercept form of a line, and that is y equals mx plus b, where the y is by itself. And then the standard form for a circle, well, you've got 2 options here. You have x squared plus y squared equals the radius squared. That's if you're centered at the origin, or if you're not, it's x minus h squared plus y minus k squared equals your radius squared. And that's where the center of your circle is that hk. Okay, so how do we actually find the solution? Well, it's a lot easier if you solve the equation of the line for the y. So you make it look like y equals mx plus b. How come that's easier? Well, because then you can use substitution. Remember that from system of equations with lines? We're going to do that again here. So I'm going to substitute the whole equation of the line in place of the y value into the equation of the circle. Now, at this point, I'm going to solve the new combined equation for x, because I should only have the x variables left. If you have any y's in your equation, then you missed a step in the substitution. So go back and check your work. Everybody should be an x term at this point. After you solve for x, don't forget to go back and find your y value, because you need to be able to write your answer as a point which looks like x comma y. So you need 2 numbers, or more if you have more than one solution. Like you saw, we could have 2 solutions. Okay, so once you've filled all that in, we're going to move on and get to some examples. Now that we've got all the steps figured out, let's actually try to put this all together. I'm going to start you off a little bit nicely. The first one, you can see the equation of the line is already solved for y. So I'm just going to substitute everything that y equals right in for the y into the second equation. So I have x squared plus parentheses x minus 3 squared equals 9. Remember from your algebra days, when a parentheses has an exponent on it, you do not distribute the power, you write it out. So I'm going to write this parentheses twice, because now little alarms should be going off in your head and you should be thinking of FOIL. I'm just going to keep bringing this x squared down. So here I go. First, x times x is x squared. Outer, x times negative 3 is negative 3x. Inner, negative 3 times x is another negative 3x. And last, negative 3 times negative 3 is a positive 9. Okay, now I have a quadratic equation, so I want to combine like terms, and I want to make it equal 0. So x squared and x squared is 2x squared. Negative 3x is negative 6x. Now these 9's are like terms, and I want to make this equal 0, so I'm going to bring it over. And this is handy because it actually cancels out on both sides, so you're left with equal 0. But when you've only got two terms in a quadratic equation, to factor it, you can't factor with two parentheses. You need to factor by looking for a greatest common factor, or GCF. So 2 goes into 2 and 6, and both of them have an x term. So if I factor out that 2x, which remember factoring is really just dividing, I'm left with x minus 3. Now at this point I like to do what's called mini equations. Every term that has an x in it gets a mini equation. That equals 0. And I solve each one, and I get two solutions. However, this is not my final answer because I need to go back and solve for y. Now I'm going to use the equation of a line up here because that's a little bit easier. So for this one, I'd have y equals, instead of x, I'm going to say 0 minus 3. So I get negative 3. So this answer is 0, negative 3. There's one solution. And in the next one, instead of x minus 3, I say 3 minus 3, which is 0. So I plugged in 3 and got 0 as my answer. So those are my 2 points of intersection. All right, let's try another one. What happens if it doesn't work out so nicely? Okay, well, started off pretty okay. It's already solved for y. So remember, again, we substitute that in. Now I'm going to jump right to the writing it twice step. 2x minus 4, 2x minus 4 equals 13. If I FOIL, I get 4x squared minus 8x minus 8x plus 16 equals 13. Again, combine your like terms. Minus 16x, and you want to make it equal 0, so I'm going to bring that 13 over, and that's a positive 3 equals 0. I've got 3 terms, so let's try to factor this. Numbers are small enough. 5x squared is 5x times x, and 3 is 3 times 1. Now I'm trying to make that 16. Will this check? 1 times x is 1x, and 5x times 3 is 15, and 15 and 1 will give me a negative 16, but only if they're both negative. And check, negative times negative is positive 3, so we're good to go. Again, do my mini equations. Everybody that has an x gets an equation. And I solve, I get 1/5 and 3. Don't forget to go back and find your y values. So 2 times 1/5 minus 4 is going to be negative 18/5. So I'd write 1/5 negative 18/5. And here, 2 times 3 minus 4 is 6 minus 4, which is 2. So 3, 2. So I still get 2 solutions. One is integers, one's fractions, but I was still able to find the 2 answers. Okay, so that's 2 solutions. Well, remember we also had other options here. We had one solution and no solution. So let's see what happens in example C. Well, we're kind of nice here, and I already told you that x equals negative 4. So while I know it said solve the equation of the line for y, you might not have a y. So use what you have. If I know that x equals negative 4, let's substitute in for x this time. So negative 4 squared plus y squared equals 16. Negative 4 squared is 16. Since I'm just left with a y term in here, let's get the y by itself and see what happens. Well, y squared equals 0. To undo the square, you square root both sides, and that cancels that out. And I get y equals 0. Well, I only get one answer. So I plugged in negative 4, and I got 0. So that's an example of a one solution type of problem. Alright, well, remember the last option was no solution, so let's see what that looks like. Okay, well, made it a little bit more difficult because the equation of your line here is not solved for y. So 2y minus x equals 8. I want to add x. 2y equals x plus 8. Divide everybody by 2, not just the number. And I get 1/2 x plus 4. That is what I'm going to substitute in over here. Now to make this one extra tricky, I even gave you another parentheses with a 2 on it for the x. So I'm going to go ahead and write everything out. So x minus 3, 1/2 x plus 4. Since everybody's squared, I'm just going to write it all twice. Equals 4. Oops. Okay. So I'm going to jump right to what happens when I FOIL here and combine like terms. So x squared minus 6x plus 9. And while foiling with fractions looks really scary, this one actually works out to be not that bad. You get 1/4 x squared plus 4x plus 16 equals 4. Let's combine like terms. 1x squared and 1/4 x squared makes 5/4 x squared. Negative 6 plus 4 is negative 2. 9 and 16 is 25. Don't forget with quadratics, you got to make them equal 0 before you can even think about factoring. Alright, now, I don't really like to deal with fractions, so if I multiply the entire equation by the denominator, it'll knock it out. So I get 5x squared minus 8x plus 84 equals 0, which is enormous to try to factor. I don't necessarily want to try that, so I'm going to tap into my Algebra 1 skills, and I'm going to remember about the discriminant. So remember the discriminant, it was b squared minus 4ac, and we used this to see if we're going to get 2 solutions, 1 solution, or no solution. So let's see how many solutions I'm going to get before I sit there and try to find it. B is my negative 8, so negative 8 squared minus 4, A is 5, and C is 84. And if I punch all that into my calculator, I wind up getting negative 1,616. And because I got a negative answer, I know that this is going to have no solution. So I'm not going to bother trying to factor it. I'm done. I know that that has no solution. Okay, so that's what the 3 different types of answers look like with different examples. So let's have you try some now on your own. Okay, so now here are 3 examples for you to try. I want you to model them after the examples that I worked out for you. I want you to find the intersection or intersections of each paragraphs algebraically. Check your answers graphically using your calculator. Now, a little tip for how to plug these into your calculator. You have to solve both of your equations for y. However, for the circle equation, you're going to need to square root. And remember, when you square root, you get a plus or minus on a square root. Okay, it has 2 answers. So you're going to actually enter those in as 2 separate equations into your calculator to show the positive square root and the negative square root. So you have to trick your calculator into graphing a circle, but it can be done. And if you need help with the checking graphically, I can help you with that in class. And then I also gave you a word problem down here to show you how this skill can be applied in the real world, so we say. Okay, so try these examples, these extra 4 problems, and then we'll check your work in class.